everyone. Good morning. Today, let us talk about comparing boosting algorithms, different varieties of boosting algorithms, CatBoost, LightGBM, as well as XGBoost. Boosting algorithms are tree-based, sequentially layered models, sequentially layered weak decision trees put together to deliver strong and robust model that usually isn't prone to overfitting. They are powerful tools in machine learning, especially for structured data tasks. CatBoost, LightGBM, and XGBoost are among the popular boosting frameworks, each with its own unique characteristics, strengths, and weaknesses. Now let us see, based on each of the ideas, how do these differ from each other? Your LightGBM, XGBoost, as well as CatBoost. Now, if you see the core concept and algorithm, CatBoost is being developed by Yandex. It focuses on handling categorical data natively. It utilizes ordered boosting, reducing overfitting and bias in datasets, and it is based on gradient boosting decision trees. Now, LightGBM, that way is developed by Microsoft. It uses histogram-based algorithms for faster computation, and it focuses on scalability and efficiency for large data sets. It implements leaf-wise tree growth, potentially leading to deeper trees and better accuracy. XGBoost, on the other hand, is developed by Tianqiu Chen. It is known for regularization techniques to improve generalization. It combines gradient boosting decision trees and system optimizations, for example, parallel computation. It also supports pruning and handling sparse data. Now, when it comes to handling categorical data, CatBoost natively handles the categorical data without pre-processing. Without the need of encoding. Right? During training, it uses statistical techniques to encode categorical features for training the model, of course. It is ideal for datasets with many categorical variables. Now, on the other hand, LightGBM can handle categorical features via pre-processing or categorical split, but requires manual setup. And XGBoost also requires your one-hot encoding or label encoding techniques. Similarly, when it comes to performance and speed, CatBoost is usually slower training than LightGBM, but often comparable to XGBoost. It also exhibits strong performance on datasets with categorical features. Similarly, LightGBM is fastest among the three due to the histogram-based computation. It is efficient for large datasets, hence, with millions of rows and features. XGBoost, on the other hand, is typically slower than LightGBM, especially on large datasets. If you see the ease of use, CatBoost is more user-friendly and requires minimal hyperparameter tuning because it handles categorical data seamlessly. Similarly, XGBoost is also more mature with extensive documentation and community support. Now, LightGBM that way requires careful hyperparameter tuning for optimal performance. And for new users, it requires some level of learning curve. Now, when it comes to overfitting, so your CatBoost is usually ordered based on ordered boosting. And since it also has overfitting detection mechanisms, the possibility of overfitting is very less. In LightGBM, since it is a leaf-wise tree growth concept, it can overfit if it is not regularized. Similarly, XGBoost also uses regularization techniques internally to help mitigate overfitting issue. Now, when it comes to parallelism and scalability, CatBoost has built-in support for CPU and GPU training. But LightGBM exhibits excellent level of parallelism and scalability both on CPUs as well as GPUs. It supports distributed training on massive data sets. But XGBoost, that way you can also say that it supports distributed computing, but definitely lags behind LightGBM. As we come to ecosystem and community, CatBoost at this point is relatively new, so the community is growing slowly, but it is still less mature than XGBoost and LightGBM. Similarly, it has like a limited ecosystem integration compared to others. LightGBM as well as XGBoost have strong and active community with wide integration in data science tools, and it has also rich support. Use cases, when it comes to use cases, CatBoost is best suited for datasets with many categorical variables like business, e-commerce, and healthcare applications, while LightGBM is preferred for datasets with numerical features. It is usually mostly applied in finance, fraud detection, and recommendation systems. XGBoost is a general purpose and suitable for computations and varied datasets. So mostly predictive modeling tasks, all of it, you find it being applied. Now, the summary table summarizes the comparison of all the boosting algorithms as we spoke against different features. Each of the algorithm, how does it compare? So we understand that boosting offers powerful tools in machine learning, especially for structured data tasks. So CatBoost, LightGBM, and XGBoost are among the most popular boosting frameworks. Each compare against each other with unique characteristics, strengths, and weaknesses. CatBoost is used if the dataset has significant categorical data, or if speed and efficiency is a criterion, LightGBM is better. And if we need flexibility and robust regularization, XGBoost is recommended. This is the end of comparative study between the boosting algorithms. Thank you so much.